Okay, this is going to be a two-part problem. It's given that a 13-foot ladder is leaning against a house and the base starts to slide out. Let's draw a picture that describes the situation. Okay, so we have a house right there. We have this ladder. The ladder is 13 feet, and then what's happening is this end is sliding out, and that's going to cause this side to fall. Okay, now this is moving out. It says by the time the base is 12 feet from the house, the base is moving at a rate of 5 feet per second. That's going to be this dimension right here. They're asking us to find the rate at which the ladder is falling down the side of the house. Okay, before we start labeling what information has been given, we have to set up our variables. Let's set up the y as the vertical distance and x is going to be horizontal distance. Whatever letter you choose doesn't really matter. We just have to set up some variables here so that way we can label the correct information and use the right formula. Alright, so x is moving to the right 5 feet per second. What is that? That is our dx dt. dx dt is given as 5 feet per second. It says by the time the base is 12 feet from the house. Okay, the base, that's going to be your x. That's 12, so x is equal to 12. We should go ahead and solve for y at the same time because they'll probably have to ask us for that later too. Now if I have 12 and I have a 13, that means the y is going to have to equal 5. So I'm going to put y equals 5, and then I'm going to put Pythagorean Theorem, basically how you can find that again, or you know it's a 5, 12, 13 special triangle. Now what I just mentioned there, Pythagorean Theorem, that's what we're going to use actually for the whole problem when we solve for this here. I'm going to start with the formula, Pythagorean Theorem, x squared plus y squared equals 13 squared. That's the main formula I want to use here. That's the relationship with the sides as given. I'm going to take the derivative with respect to time. 2 comes down, 2x, I have dx dt, 2y dy dt, and then I get 169 on that side, but derivative of that's going to be 0. So this is my finished equation once I've done taking the derivative implicitly with respect to t. I'm ready to plug in the given information. Now, what is this asking me for? Find the rate at which the ladder is falling down the side of the house. Well, because I labeled that y, that's going to be our dy dt in this formula. That should be the only unknown because everything else we have given. Let's put in the given information. We have the x is going to be 12, the dx dt is 5, and I have 2 here, the y is going to be 5. dy dt, again, I just mentioned was the unknown, and I have it equal to 0. So now I just need to solve for dy dt. Okay, this part is going to be 60 times 2, 120, plus 10 dy dt equals 0. Can move that to the other side. 10 dy dt equals negative 120. And then when I divide, I'll get my answer. Dy dt is equal to negative 12. Let's look at the units on it. It's going to be the same units as x, feet per second. Now, why is it negative? Well, it's negative because the ladder itself is moving down. Based on the picture that I drew here, if this is moving out to the right, that means this is falling down there. And if I think about a regular graphing axis, down means negative. So that would make sense then that I would get a negative as the answer. So now that we've done part A, let's take a look at part B. Okay, so now for part B, it's asking us find the rate at which the area is changing when the base is 12 feet from the house. So we still have the same situation. The ladder is still falling out. So in part A, we had all this information, so I rewrote all that again. Here's our picture. That's the result we got from part A was negative 12. This time we want an area. So I have a triangle, I want the area. I need to use the area formula for a triangle, which is 1/2 base times the height. So let's write that out. Area equals 1/2, and then because I labeled my triangle with x's and y's, I'll use that in my formula. So once you have the formula, we now have to take the derivative with respect to time. On the left-hand side, when we do that, we get dA dt. That's actually what part B is asking for. It wants the rate at which the area is changing. That is exactly dA dt. Now on the right hand side, when I do that derivative, because I have two things multiplied together, I got to use a product rule. The 1/2 x is going to be my f, and my g is going to be the y. So when I do product rule, I got the first thing, 1/2 x, times the derivative of the second. Derivative of y is dy dt, plus the second thing, which is y, and then derivative of the first. My first piece is 1/2 x. That derivative is 1/2, but then don't forget you need to put also dx dt there. So these are all my components for when I did the derivative. So now I'm ready to plug in the numbers and get the answer. Okay, so we're going to do that next. dA dt, we have 1/2 times x. X was given as 12. And then dy dt, that was our answer for part A. That was -12. And I have plus the y, which is 5. And then times 1/2. And then times dx dt. Okay, dx dt is 5. So now I just need to work this out, and that's going to give us our final answer. Okay, this part here, that's going to be -144 halves. Okay, -144 over 2. I want to leave it in terms of halves because this one's going to have a same denominator. This is 25 halves. Now the last thing we'll do is just subtract these, and once I do, I get -119 over 2. Okay, so this is going to be my final answer. It's negative, which means that the area is decreasing. That makes sense because as this swings out this way, this height's getting smaller and smaller and smaller. It's a smaller triangle, so it does make sense that at that instant my area should be decreasing. The units on it, what would it be? It would be feet squared per second. Area is always in terms of square feet, and then we have seconds as the same unit of measurement that was originally given.